There are 5 colors that you're going to need. The one thing I want you to write underneath the words unit circle. The reason why it's called a unit circle is because the radius of this circle is 1. So underneath unit circle, just write radius equals 1. Kind of like I did on mine. So I just wrote radius equals 1, kind of near the unit circle part.
Wait, does that have to be in a color?
No. So, like I said, there's 5 colors because if you look at our handout, there's 5 different blanks you're going to fill in. So these inside ones are going to be angles, and where this helps us is instead of having to rework these values every single time for these certain angles are used quite a bit. So if you notice, there's 3 different angles in between the main turns of the circle. So these are the most common angles that we use. So we're going to fill out the degrees. This one's going to be the radians, and then each one of them has a certain value that's related to it. So instead of having to figure them out each time, what we did is created a unit circle handout so that we can use that to help us look up certain values that we need in the future. So, like I said, our unit circle will eventually look like this. I'll show it to you a little bit at a time, but I will say if you are color coding, you'll want to, and even if you're not, you'll need a little code area so that you can say what colors are going to go with what values. Like I said, even if you're not color coding, you'll want to make sure you list that, so that way as you're going through, you won't have to remember every single time. You can help use that little thing. So you can either use it up in the little corner. Mine's kind of worse for wear, but I've kept this for a few years. So I just have it up here in the corner. You can do it over in the other corner, because I also added a place to put your name. You can use it on the back, but eventually we will be adding a few things to the back, so just a couple places to put it. Alright, so your first color, you're going to go through and fill out all the normal degrees that we use. So that's all filled in here. So we have 0 degrees. Now if you notice here is the starting point of our circle, and it's also the ending point of the circle. So this one actually has 2 different degree measurements. So the number above the line is 0 degrees. So that's where it starts. The number below the line is 360 because that's where the circle would end. The only other thing is I noticed too late that my degrees and radians are flip-flopped up here. So the degree on your paper is to the left of the line, and the radian spot is to the right. But wherever you see on the inside of the circle, there's a little degree symbol. You're going to fill out these common degree measurements around our circle. We have 0, then 30, 45, 60, then a quarter rotation is 90, and we keep going from there, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. So that is your first color. And then eventually I'm going to move the little green boxes. Because next to these we have common radian measurements. So that will help, what this helps is it helps do a quick conversion too. So that way if you say, okay, I have 45 degrees, but I really need it in radians, you can actually look here to help do quick conversions. Because there's certain radian measurements that are very commonly related to degree measurements. As we know, like 360, 2 pi, those are related because 360 is a rotation in degrees, 2 pi is a rotation in radians. Pi and 180, we use that as a conversion. So there's several different radian measurements that are linked to degree measurements, and this will help you do that conversion really quickly. Now, this doesn't mean that these are the only degrees ever. These are just the most common degree measurements that we use. So then your second color is the radian measurements. So I'm going to start revealing those. That's what's underneath the green boxes I have up here. So yeah, that's going to go next to the line on your unit circle handout. So you should have filled out the line that has the little degree symbol. Next to it is this little blank line. So that's where your radian measurement is going to go. So 0 degrees is also 0 radians. Okay, so the start is 0 no matter what. Okay. So again, there's two different measurements here for degrees and for radians. Because again, this is our starting spot and also our ending spot. So if it's our start, it's 0. If it's our end, it's 360 or 2 pi in radians. So again, on our circle, it starts and ends in the same spot. So that's why that's the only spot that has two different measurements for it. So then next to 30, the radian measurement that goes with that is pi over 6. And you can either write it above the line, or you can use the line as your fraction bar. It's up to you. Because all these, for the most part, are fractions. 45 degrees is pi over 4. 60 degrees in radians is pi over 3. 90 degrees in radians is pi over 2. Like so, these two are switched. So your 90 would be here, pi over 2 would go on the other side.
Pi.
Nope. 120 is 2 pi over 3. 135 is 3 pi over 4.
3 pi?
3 pi over 4, yeah. 150, 5 pi over 6. You might start to notice a little bit of a pattern with the denominators as you go through. What's going to be one next to 180? Pi. Yeah. We've known that relationship for a while. That's what we use for conversions. And I remembered that. That's okay. 210 is 7 pi over 6. 225 in radians is 5 pi over 4. 240 degrees in radians is 4 pi over 3. 270 in radians is 3 pi over 2. Is anyone noticing there's similar denominators? So it's either over 6, 4, 3, or 2. This next one's going to be over 3 because it's closer to the y-axis. 5 pi over 3. The one in the middle is always over 4. So 315 is 7 pi over 4. And then the last radian measurement is listed next to 330. It is the only unique one because it's the only one that has a double digit on top with pi. It's 11. So you had pi over 6, pi over 4, pi over 3, pi over 2, then 2 pi over 3, 2 pi over 4, 5 pi over 6, then pi, and 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and then 2 pi. So like I said, one way we can use this is it gives you a quick conversion between degrees and radians. So if you have something as a degree and you need it in radians quick, you can just look here instead of having multiplied by pi over 180. Now if it's a degree that doesn't live on this unit circle, we'll still have to use that conversion of pi over 180. But again, that gives us kind of shorthand for it. And also the opposite way, if you have a radian and you want to know what the degree is, you can look here and do that. Okay? And also it gives you nice values that are in between 0 and 360 or in between 0 and 2 pi. So that way you know that these values are going to be in there. Also notice that they're positive angles. That means that we're rotating counterclockwise. If we ever are working with negative angles, that's rotating clockwise instead. So you might have to do a little bit of the coterminal angle thing to find an angle between 0 and 360. So like adding 360 or adding 2 pi we have negative angle, so that way we get it somewhere on the unit circle. So we use some of the same things we did with coterminal angles and conversions when we're trying to use the handout. So if you're not given something quite like this angle that we have here, because all these angles are in between 0 through 60, we can use that coterminal angle thought process where we had to add or subtract stuff to get something on the unit circle. Okay? So now we're on to our third color. Flip to the blank one real quick. So the next one we're going to fill out, we're actually going to go through and fill out all of the X values, because the X values all around the circle correspond to one particular value. And so this comes from is, so we have our degrees, our radians. The next one is a cosine value, sine value, and tangent value. So they're going to be our three main values for our trig functions. So sine, sine, and tangent is how the code will work out. Okay. So the next thing we're going to fill out is X values. And that's going to be our third color. So in our color key code, cosines are X values. So like I said, whether you're color coding or not, you need to make sure you write that somewhere on the paper so you can remember that all of the X values, or the first values in our ordered pair, correspond to a cosine value. Now, the one thing is they only have the three main trig functions on here, cosine, sine, and tangent. But that doesn't mean we can't find the other three values, as we've been working with all 6 ratios for a long time. So we can also use the cosine to help us find secant, because secant is just the reciprocal of that. So this first value that I'm going to show you is the one next to 30 degrees. So that X value is square root of 3 over 2. And like I said, you can use that bar in there as your fraction, because all these are going to be fractions to help you kind of squeeze it in that handout. Okay, now you don't have to draw the triangle, but I just wanted to explain a little bit of where these values are coming from. So we know that the radius is 1. So this red line I drew in here is going to be 1. And then we know the angle is correspondent to this degree. So we know that this side is 1, this angle is 30. And so then what they did is they used SOHCAHTOA and the Pythagorean theorem to help find the y value, which I highlighted in blue, and the x value out in the green. So that's where it's all coming from. It's all coming from a right triangle that we can make with all of these points that are on a circle. Drop down. Again, this is our sine value. This will be our cosine value, because cosine corresponds to x. Because remember, x was like the adjacent side, and so the adjacent side for cosine, or the cosine was always adjacent over hypotenuse, which our hypotenuse is always on, or it's always 1. So it's whatever the x value is. Okay. So the square root of 3 over 2 is our first x value. So then the next one, same color, square root of 2 over 2. And all these are going to be exact values, so they're all going to be square roots and fractions. But again, they're the exact values that correspond to, imagine drawing a little right triangle in with each one of the points. So the next cosine value is a half. Now they all don't have square roots, okay? So some of them are just fractions, but again, they're exact values. It all comes from drawing a little right triangle to every single one of these points. Am I going too slow? So the next thing I want to do, so that's 0, okay? Because if you think about x on that, you're not moving it left or right to get to this point. Because that's what they're corresponding to, is these little points all along the edge of our circle. So that's the x value for that point, which makes sense, because to get to that point, you don't have to move left or right or any, you're just moving up.
So wouldn't that mean the bottom's also 0?
You'll start to notice some patterns with these. Okay, so think about this point. To get to this point, it's about a half this way, because that's where we're listing as x values. How much do we have to move left or right? Well, this point is the same distance, only now we're moving to the left, and we know on the left side of the x-axis, it's negative. So this point is about the same distance as this point, so this one's going to be negative square root 2 over 2. So there's a nice pattern that goes along with this. Any guesses on what the next one is? Negative square root 3 over 2. And then this point is the same as this point that I covered up. So this value, oh wait, I skipped over this one. So this one is going 1 whole unit, but it's negative, so it's negative 1. So the point next to pi, or 180, is negative 1. Because again, to get out to this point, we're moving left a whole radius of the circle. We're not moving up or down any. So that's negative 1. This one, this point, is negative square root of 3 over 2 as well. Because I covered up the point, but this point and this point are equidistant left from the middle.
Do you want to ask that question that you have, or do you want me to ask it? Because I thought of
What?
the same question.
What's this next?
It's gonna be the same thing. It's gonna be
Negative
reversed.
square root of 2 over 2. So there is a nice pattern to this once you start filling it out. What's the next one going to be?
Zero.
This one?
Negative 1.
Negative 1.
And we already know the next one's zero.
That was it.
Do they stay negative or do they become positive?
Alright, so now we're going for x values. Now we're going right again. So are they going to be positive or negative? Positive. Because this point here is the same distance away, only now it's going down instead of going up, but it's still going positive half.
So it means your y will be negative instead.
Exactly.
Oh, and the 0 and 3 6 you still be positive.
So square root of 2 over 2 is for the 7 pi over 4. 11 pi over 6 is going to be square root of 3 over 2. And then this one, to get out to this point, the x value is 1. Because it's a whole radius.
Now, do we need another color for the y value?
Yep. So all of those are cosine values. And I'll show you how we use this in a second, but essentially what it does is it helps us look up values for certain cosine really easily. Because like I said, the way cosine is typically adjacent over hypotenuse or x over r, because we know that our x is now our adjacent side of our triangle that we draw here. Well, now our r is just 1, so it's just whatever the x value would be. So this allows us to look up a cosine value really easily, because it's usually x over r, which it's over 1, because the radius of this circle is 1. So now, what we're going to do is fill out the y value, which are your sine values, okay? Because remember, sine corresponds to the opposite side of the triangle, which opposite we now defined as the y value of an ordered pair, okay? And again, we're just listing them as sine values, but we only list the 3 main ones on the unit circle: sine, cosine, and tangent. But we can always find the other 3 because cosecant is just the reciprocal of this. So like this would be your cosine value. The secant value would have been 2 over 1. So just flip them. Yep.
So then top and bottom are going to be 1 and then negative.
So this one, we're now looking at this distance that we're going up to because it's a y value. So now we're moving along the y-axis instead of the x-axis. So this one moves about halfway up there. So our sine value for that first point is a half. To get to this point, again, it was about this distance here on the x-axis for cosine. Notice it's about the same distance. So that's why the sine value for this is also square root of 2 over 2.
Oh, it's a 45-degree angle, so it is the same distance.
Exactly.
So it has to be.
Okay, for the next one should be the square root of 3 over 2.
Just genius.
Well, but this pre-calculus is smarter.
I know. No, there's what you shall notice is there's a nice pattern, and it all comes from the little triangle that's drawn, and it depends on which one is the longer side. So then this is 0 for cosine, but for y, to move up here, it's going to be 1 because it's the radius of the circle. Now again, this point is at the same height as this point that I've covered up. So it's still moving up a roughly the same. And since we're still going up, our y values are still going to be positive. So at 120 or 2 pi over 3, the sine value is square root of 3 over 2. I guess it's on the next point.
Square root of 2.
Yeah, square root of 2 over 2, because these y values are still positive because we're still going up. Okay? Because don't forget it's ultimately on the x and y axis. So as you're moving right, x will still be positive. As you're moving left, x will be negative. As you're moving up, y will be positive. As you're moving down, y will be negative. Okay? So then this next one is going to be a positive half for the sine value, the y value. So for this point, are we moving up and down any?
No. It's
No.
0.
So the y value is 0 there. I notice some similarities between the pairs as well. So the square root of 3 and 1/2 are always paired together. Sometimes one's negative. Sometimes they both might be negative. And then 0 and 1 are paired together. Square root of 2 over 2 is paired with the square root of 2 over 2. So you'll notice some patterns. So in this one, now we're going down. So what's the sign on my y value is going to be if I'm going down?
Way too long to find.
Negative. Yep. So that's going to be negative 1/2. This next one's going to be negative square root of 2 over 2. Again, we're doing y values, so y values are going down, so since they're all going to be negative. Okay? So then this one is going to be negative square root of 3 over 2. So then to get to this point, again, we didn't move left or right any, so it's 0, but we are going to go down, and it's the whole radius of the circle. So since we're going down, it's negative 1.
Just like a coordinate.
You're traveling the same distance away. It took me way too long to figure that out.
So then for all of the rest of them, we have to take the tops and put them together.
Alright, so then this one, again, we're still going down. So this one's also negative square root of 3 over 2.
So it would be y over x for the rest of them. So it'd be the
For
right
tangent.
order.
Then this next one, again, it's still going down the same distance this point did. So it's going to be negative square root of 2 over 2. And that's paired with the 7 pi over 4, or 315.
Oh.
Scary.
This next one's negative 1/2. And then the last one is 0. Okay. Any questions on those two, or the first several values? Okay. So now, what we're gonna fill out now is the tangent values, which cosine was typically x over r, but in this case r is always 1 because that's the radius of the circle. So that's why cosine is just the x value, and sine was y over r, but again the r is 1, so it's just the y value for sine. For tangent, how we get them is it's y over x. Okay. Now, typically in a normal unit circle, they actually just give you sine and cosine, because once you have sine and cosine, you can literally find all the rest of them. But to have to do tangent every single time where you're taking a fraction and dividing it by another fraction gets a little frustrating. So I added an extra dash on the outside to fill out the tangent. So this is your last color. So it's not technically part of the official unit circle, but again, I'm trying to make it so that you can use this quickly. So again, the way we get tangent values is once you have sine and cosine, it's y over x. So you can take this, and this is why I'm not making you do this every single time. So it's telling you to take y and divide it by x, okay? So that can get frustrating to do every single time when you're trying to find tangent, because you have to remember how to divide a fraction. Well, I have to multiply by the reciprocal. So it's 1/2 times the reciprocal of this, okay? Which when you multiply across 2 over 2 square root of 3, which we can get rid of the 2's. So it's 1 over the square root of 3, which we don't like the square root on the bottom, so it's square root of 3 over 3. So that's why the tangent value of this is square root of 3 over 3. Okay? You don't have to do that every single time because I'm giving you those values. Yep.
Isn't that the same thing as taking the y top value and putting it over top of the bottom, the top x value? So 1 over square root of 3 and then solve. Top value over top value.
Well, yeah.
Will that work every time?
Yeah.
Value?
Because
So
the bottom
then
is
all the
cancel.
45-degree angles would just be 1.
We're supposed to write that down.
They do either
So you don't
one
write this
or
part
negative
down,
one.
okay? So this I just showed you where I got that number. So instead of making you figure that out every single time, I'm just giving you those tangent values. So then this would be the square root of 2 over 2 over the square root of 2 over 2. But since you're dividing the same two things, it's going to be 1. Okay? Okay? This tangent value is just doing the opposite of what I just did here. So it's going to be kind of the opposite of that. It's actually the square root of 3.
I didn't sleep actually.
Okay? Now this one, if I put y over x,
Fine.
it's undefined. Yep. So there is possibility for tangent to be undefined because if x is 0, then tangent's going to be undefined. So I put the fraction there, but ultimately remember that tangent is undefined. So there are going to be a couple values that are undefined here. Okay? So then this point comes from these same two values, only now we're dividing a positive with a negative. So my tangent is going to be negative square root of 3.
-1.
This one's going to be -1 because again you're dividing a positive with a negative. So whenever you divide a positive with a negative, it's negative. This one's going to be negative square root of 3 over 3. So there's also a pattern with these. This one's going to be 0 because 0 divided by -1 is 0 because 0 can be 0 divided by anything is 0. Okay, then this one is going to be square root of 3 over 3 because we're dividing a negative with a negative. When we divide two negatives, it's positive.
First class.
Finish it. Okay.
Wait, what?
So there's a nice pattern for it. Okay, make sure you write the rest of the tangent values down because tomorrow we're going to start up with the blue packet.
Sounds like a lot.